This is part 5 of the Ontario Apple IPM workshop series, Direct Insect Pests Summer. My name is Christy Grigg-McGuffin. I'm a horticulture integrated pest management specialist with Ontario Ministry of Agriculture, Food and Rural Affairs. Throughout this series, we're going to be discussing various insect and disease common to Ontario apple orchards, including their identification, biology, how to monitor for them, as well as some general management practices.
So before we get into a discussion on the particular insect pests, I wanted to just touch base on what is meant by a direct versus an indirect pest. And now this really depends on what part of the plant is attacked. In apples in particular, a direct insect pest feeds specifically on the fruit, whereas an indirect pest is an insect that attacks the leaves, the trunk, or any other part of the tree. Now, major pests have the potential to cause some major economic loss, and in most cases, direct pests are also considered major pests. And while indirect pests may limit fruit yield, they're often considered minor pests. That does not mean that indirect pests cannot cause significant economic loss in an orchard. In this presentation, we're going to be discussing the direct insect pests that are present from bloom up until harvest in an orchard. And these include oblique-banded leafroller, codling moth, apple maggot, European apple sawfly, and stinkbug. While oriental fruit moth is active during this time, it was discussed in part 4 of the webinar series, so please refer to that presentation for more information. Starting first with oblique-banded leaf roller, this is often early season, included within that spring feeding caterpillar complex. However, activity does extend well into the season and it can cause some serious economic impact. So oftentimes oblique-banded leaf roller is monitored and managed on its own. You may see eggs present in the orchard. These can be laid in groups, often resembling overlapping scales on the surface of the leaf. However, they're not often found and not included in part of the monitoring program. What you will likely see are larvae rolled up in the leaves, and we'll talk about damage just momentarily. The caterpillar can appear cream to white color with a dark head capsule. The adults are quite large bell-shaped moths, tan in color with dark bands along their forewings. Now, oftentimes you won't see activity as they're active at dusk, but these are insect pests that are monitored using pheromone traps. So you'll see these quite distinct on the traps if monitoring. In terms of damage by oblique-banded leaf roller, this is kind of the typical appearance of what we'll see. And so true to their name, the caterpillars roll within leaves, forming these nice loose curls. Oftentimes there will be presence of webbing. You can see some evidence of the silk webbing to hold that leaf in a roll. There's also oftentimes presence of frass as there's active feeding within that leaf. This is just insect excrement. And presence of that feeding, they make these window pane feeding holes as they're rolled inside and protected inside that leaf. Now they will complete their life cycle within this leaf, so you will see evidence of a pupal case as the adults emerge out. Why oblique-banded leaf roller is classified as a direct insect pest is that a surface feeding can occur on the fruit, in particular those that are in close vicinity to the leaves. And it can almost happen by accident as the leaf roller is feeding on the foliage. It can feed superficially on the surface of the fruit, and this can leave scars and deformed fruit as the fruit continues to grow and develop. So leaf roller overwinter as laid instar under the bark within the orchard, and the larvae start to become active about tight cluster to bloom, as we discussed with spring feeding caterpillar. The summer generation, however, is active from petal fall right up until harvest. And so now there's 2 generations, but there's 3 feeding periods per year. So the overwintering larvae feed on the developing flower buds and the growing fruitlets. the first generation or summer larvae tend to feed on those growing terminals, that nice soft tender shoots. They can also feed on that developing fruit if it's in close vicinity to those developing shoots. And the last feeding period is that second generation or late summer fall larva. And these feed primarily on the leaves. So monitoring can be done through visual observations looking at terminal damage. There are thresholds that have been set for oblique banded leaf roller. So if 1 to 2% of the terminals that were assessed were infested with oblique banded leaf roller, then that warrants a spray for both that overwintering generation as well as the summer generation. However, for the summer generation, typically they're monitored using pheromone traps, and these are installed at petal fall. And so there is a threshold, a degree day threshold that is set in terms of implementing control for that summer generation. There are some varieties that tend to be a little bit more susceptible to damage from oblique banded leaf roller. However, there are not dedicated varieties that are considered resistant. Really, it's ideal in terms of trying to create habitats that are not appealing to oblique banded leaf roller. So trying to thin fruitlets as much as possible, pruning and reducing the canopy growth, as well as avoiding any sort of excessive vegetative growth, because they do prefer those lush succulent shoots. So trying to limit the use of nitrogen as much as possible, or consider the use of apogee for petal fall control of shoot growth. There are some parasitic wasp and flies that can suppress oblique banded leaf roller populations. You can see in the pictures on this slide evidence of parasitism that's occurred with that oblique banded leaf roller pupa. However, this is not something that does provide complete control, so there would be a need for chemical control if populations are high. Now, with chemical control, there is some concern about resistance to some groups of control products. So it's advised to please be sure of the efficacy and in your orchard when using these products. Another moth pest that's active in that summertime in apple orchards is codling moth, and this is one of our primary pests of concern in apple orchards. So the larva looks very similar to oriental fruit moth, with this kind of cream pink color, brown or black head capsule, and these are internal feeders. So these would be larvae that would be found within the fruit itself. The adult is larger than oriental fruit moth, and it has brown and gray banding, but with a really distinct copper or bronze patterning, a half moon shape on the tips of the forewings. So you can see the size difference between oriental fruit moth and codling moth in this great picture shown here. Oriental fruit moth is quite a small moth in comparison. The other difference, if you're dealing with the larva stage of these pests, is to look for presence of an anal comb at the end of the caterpillar, shown here in this picture. And so oriental fruit moth has an anal comb, as opposed to codling moth, which does not. The other way of determining which species you're dealing with, if you're seeing this internal damage, is to look at the damage itself, which I'll discuss in an upcoming slide. So codling moth damage, this is, as I mentioned, it's an internal feeder. So as the larva hatches, it tunnels into the fruit, and it begins to feed directly on the seed cavity. There are often signs of entry by presence of frass plugging the entry and exit holes of the fruit. However, this can sometimes be difficult to see depending on where this entry occurred. If they entered in through the calyx, sometimes it can be easy to miss this damage when going through and scouting. And so, as I mentioned, there is a difference in terms of the damage by codling moth and oriental fruit moth. Codling moth is an internal feeder that feeds directly on the seed cavity, whereas oriental fruit moth does not feed on the seed cavity, but rather tunnels around in the flesh around the outside of that cavity. So similar to other moth pests, codling moth overwinters as a late instar under the bark of the tree or in the leaf litter, or it can be in brush piles or hedgerows surrounding the orchard. The adults typically begin merging around bloom time, and then the summer generation then emerges into that later summer, into that fall time. So monitoring for codling moth can also be done through use of pheromone traps, similar to oriental fruit moth, whether it's the use of the diamond trap as shown here or a delta trap with the removable liner. And these traps can be used to either establish a biofix for degree day modeling or to just verify the success of mating disruption program. So these traps would be installed in bloom in order to be up ahead of the adult flight activity, and it's ideal to include multiple traps in an orchard just to get a good representation of the flight activity that's happening. With calling moth traps, though, in particular, if mating disruption is being used, it's ideal to place these traps as high as possible within the canopy. So this it may take some modification depending on the height of the tree. You can see in this picture below here on the left, what I've done is modified a bamboo stick with a hook on the end. And I find with very large trees, it's best to use delta traps as opposed to diamond traps, just because they do have that wire hook that's much easier to be able to get up into those high reaches. So it's important to be able to identify the distinguishing characteristics of the pest that you're monitoring, as you can get some bycatch, some other similar looking moth species on traps. And so being able to identify which species will help, especially if you're setting things like biofix where you're looking for the first trap catch. So in terms of managing codling moth, trying to limit the overwintering sites in and around the orchard can really help reduce populations. And so that's trying to remove things like wood piles, fruit bins, any sort of loose bark that may be around or in the orchard, as these would be sites that they would prefer for overwintering. There has been some use in terms of using exclusion netting, in particular using in Quebec, finding success for limiting codling moth damage. There's also fruit bagging options that are available. This is more common with smaller acreage or with organic farms, and this is making use of things as simple as nylon footies covering the developing fruitlets and preventing the codling moth from actually entering into the fruit. Similar to that, something like the use of surround or kaolin clay can also work in a similar way by making the surface unappealing for the larva to enter in. There are some beneficial insects that are around that can provide some efficacy against codling moth, but it does not provide economic control if used alone, especially under high pressure situations. However, there is a granulovirus that has been developed specific for codling moth. And the interesting thing about this granulovirus is that the viral bodies will actually continue to grow and release after the death of the insect. So it can continue to infect other codling moth larvae in the area. And mating disruption is commercially available for codling moth. However, it's not as effective as it is for oriental fruit moth. It's best when it's used in combination with an alternative program as well. In particular, granulovirus with mating disruption has been quite successful, or making use of a limited chemical control program as well. So similar to oblique-banded leaf roller, there are some concerns about resistance management if chemical control is used. So it's really important to understand the efficacy of the products that are being used in the orchard and how they're targeting codling moth pest. Next, we're going to speak about apple maggot. So this is a fly pest in apple orchards. And it has really distinct banding that I'm just going to focus on for a moment in terms of their identification. So how to determine, to identify the apple maggot from related species is the presence of the F banding on the wing. As you can see in the pictures here, it's very distinct F banding. Now, there is a difference too between males and females, and this is important in terms of being able to identify where the activity is at in the orchard. So with the males, they have a rounded abdomen with 3 white bands, whereas the female has a pointed abdomen with 4 white bands. And again, this is important for being able to understand the activity of the population, as males tend to emerge sooner than the females in a typical year. So damage is often appears 2 different ways. The first is the oviposition sting that can occur on the fruit surface. So this is where the female pierces into the skin and lays the eggs within the flesh of the fruit. So these can, depending on the color of the fruit, they can be rather difficult to see when just doing a regular scouting program. The other type of damage that can happen if those eggs continue to develop within the fruit, then the larva will actually tunnel throughout the flesh of the fruit and can cause this internal breakdown and discoloration, also known as railroading. So apple maggot overwinter as pupa in the soil, and the adults typically start to emerge in late June, and they can be active right up until harvest or that first hard frost in the fall. So as I mentioned before, males do emerge before females, and there's often a period of time, a number of weeks prior to mating, where they're looking for a food source. So the use of different traps can really be effective in terms of being able to identify the activity. So yellow sticky boards can be used for that early emergence. As they're looking for food, then they're attracted to the yellow color that mimics a nectar source. So trapping using the sticky cards, the yellow sticky cards, can help indicate early activity. Once females are mated, then they're attracted to the ripe red spheres, mimicking a mature fruit, which is where they then oviposit their eggs. So having these 2 in the orchard can help indicate kind of the proper timings that are needed. So in terms of thresholds, when using a yellow sticky board, then following first catch, control is typically needed 7 to 10 days following that catch. Whereas once you begin catching on the red sphere, that's indicating that oviposition is ongoing, and so control would be needed immediately following that catch. So ideally hanging these traps up shortly after petal fall, usually that kind of mid to late June timing, and having multiple sets of these traps up in the orchard. Now you can use the traps just as the visual attractants, just with the yellow sticky board and the red sphere. You can also use commercial baits as well to enhance the attractiveness of these traps. It's ideal to hang these along the perimeter of the orchard, especially if this insect pest is not resident in the orchard itself, and that it's moving in from wild hosts. Now, removal of these alternative hosts around the orchard can really help to reduce populations of apple maggot within the orchard. So looking in hedgerows and woodlots nearby and removing those potential hosts, such as hawthorn or wild apple, can really help to limit those overwintering sites. Also disposing of any fruit that's dropped on the orchard floor that could house the development of these insect pests, either by removal or mulching, again, to help to control these population numbers. Otherwise, apple maggot is mainly controlled through chemical use. It is possible, depending on the product selected, it's possible to use border sprays for these, so long as various conditions are met, as listed here on this slide, and that the population is not known to be resident within the orchard. European apple sawfly is an invasive insect pest that we've been dealing with for some time in Ontario. The larva looks very similar to codling moth with this cream to pink colored body and a dark head capsule. The adult is a shiny black insect with a bright orange lower body, legs, and head. So as I mentioned, the larva does look similar to codling moth. The difference between these two in terms of determining which species you're dealing with is going to be about the activity, or when you're actually seeing this pest. And European apple sawfly is going to be in that early season, basically from bloom to early fruitlet development. Whereas codling moth, the activity doesn't actually occur until later season, so late petal fall and leading up until harvest. Now, with sawfly, the activity of the adults, they start actually laying their eggs during bloom, and they lay these eggs into the base of the flower. So as that fruitlet begins to develop, so is the egg, and the larva hatches and begins feeding immediately within that developing fruitlet. So there are two types of damage that can occur. The primary damage shown here in this bottom corner are these really distinct ribbon-like scars that can occur. And this often happens if the larva, say, leaves the fruit or dies prior to causing more infection. And so you just get this superficial tunneling that occurs underneath the skin, and then you're left with these scars as the fruit continues to develop. Secondary damage, however, occurs when the larva is able to move through the fruitlets within the cluster. And so you have these entry-exit holes as it moves around the clusters. This fruit may abort most cases. If it does continue to grow and develop, then you'll see this feeding damage. And I'll show that in the coming slide. So as I mentioned, this is an invasive insect pest. It's primarily an issue in orchards east of Ontario, eastern Ontario, so east of Toronto, and the Georgian Bay region. However, it is spreading further southwest of the province, so damage has been found in Niagara and Elgin County areas. So here's just another picture of the example of that ribbon lace scar that can occur with that primary feeding damage. And this can really vary in terms of the extent, just based on the activity of the larva. So if the larva was alive and well for some time, it can really tunnel around that fruit, whereas some, such as this fruit in the bottom left corner, that the ribbons can sometimes be quite small and uneasy to really determine. So feeding damage can be mistaken with plant bug injury. As you can see here, we're looking at sawfly damage compared to plant bug injury. So the feeding holes are actually quite smaller with plant bug, and you tend to have quite a bit of scarring that can occur on the fruit. In terms of the internal damage, I mentioned this before, it's really about timing. In terms of being able to differentiate it from codling moth. So the damage from European apple sawfly occurs much earlier in the fruitlet development, as opposed to codling moth, where you'd be seeing in that later season as the apples mature close to harvest. So sawfly overwinters as mature larvae in the soil, and the adults start to emerge at about pink. And so they're ready to lay their eggs as soon as the flowers begin to bloom. And the activity of this larva continues for a few weeks after petal fall. So monitoring for this can be done using either the white sticky card shown here in the top right corner, or these 3D white traps that mimic a flower bloom, and they're sticky on all sides here. And so with these traps, then you can use them to determine a threshold, and that really depends, that threshold is based on the petal fall application timing for control products, and that's based on whether pre-bloom control has been in place. So these traps would be hung up about tight cluster to pink to really be able to target that timing as the adults begin to emerge. And that continues on into petal fall as well to be able to determine that threshold timing for a petal fall control product. And you're monitoring as much as possible throughout that time period to really try and be sure what the pressure level is like over that bloom period. So because this is a pest that's active during bloom, then strategy is really important in terms of trying to determine planting sites. So if you are in a region where this pest is a problem, it's important to consider your blocks, the arrangement of your blocks, to have blooms that don't overlap widely, so that you don't have a prolonged bloom period. So due to our Ontario Bee Act, then insecticides cannot be applied during bloom. And so therefore, if there's an extended bloom period, then that increases the amount of time that the sawfly can be active and laying eggs with very limited insecticide residues available. So having a short overlap between blooming varieties can allow for that protection to be in place at pink and continue to provide any sort of efficacy over the bloom period. There has been some work done looking at the efficacy of parasitism for this pest in Quebec and some Ontario orchards, and it has been found to be quite successful. However, it's not widely used at this time, but there is definitely some potential for being able to rely on some introduced parasitism to control European apple sawfly. Otherwise, there's two timings in terms of chemical use for European apple sawfly. So a pre-bloom application about at pink or so to be able to target those adults that are starting to become active. But the most effective timing is a very early petal fall timing to control that larva shortly after bloom. And the last insect pest I wanted to touch on was the stink bug complex. So there's a number of stink bugs that are present in Ontario apple orchards. Two are highlighted here. These are two of our native Ontario stink bugs, the green stink bug and the brown stink bug. However, we do have a new invasive stink bug pest that's of significant concern for agriculture as a whole, and this is known as the brown marmorated stink bug. So in this picture, you can see here, it's a very large stink bug. It has quite distinct characteristics, and they're pointed out here. So there's the adult, both the adult and nymph have two white bands on the antenna, as well as banding on the legs. It's usually a little bit more obvious in nymphs than it is on the adults. They also have smooth, rounded shoulder tips, as opposed to some of our native stink bugs that have quite jagged shoulders or pointed tips. The really interesting thing about this brown marmorated stink bug is the length of its feeding apparatus. It's almost half the size of its body, so it can really cause extensive damage, piercing right through that fruit. And the big thing about brown marmorated stink bug is that it has a massive host range of both agriculture, forestry, and landscape pests. So it can really move around well throughout the season because it has such a wide host range. The concern, though, for apples, as you can see on this list here, is that apples are considered one of the high-risk crops for brown marmorated stink bug damage. And this is mainly because the apples provide a really excellent carbohydrate source late season as the adults are getting ready to overwinter. If you're looking for more information on brown marmorated stink bug, this is a really excellent site, stopbmsb.org. So I do encourage you to check this website out for more information on brown marmorated. So stink bug damage in general, this is kind of an image of a very progressed case of stink bug. So you can see here these sunken or collapsed and kind of discolored markings on the skin of the fruit. And then if you cut away underneath that, then the flesh under those damaged areas are quite corky and discolored. However, this is something that occurs often in apples. It occurs really late season, either just before harvest or actually doesn't start to develop until storage. So determining the extent of damage in the field can sometimes be really difficult. And you can see that in these pictures here. So these are pictures of initial damage by stink bug. And so in this close-up picture here, you can see the discoloration is just beginning. There's also a sign of the feeding puncture that's occurred there in the middle. But let's take a closer look at this picture at the bottom, bottom left here. And I'm wondering whether or not you can actually see where that stink bug damage has occurred. Did you find it? So again, it can be really difficult to be able to identify that early feeding damage caused by stink bugs in an orchard. It's also possible for stink bug injury to be misidentified with bitter pit, which is a physiological disorder common in apples. The markings do look quite similar. However, with bitter pit, the margins tend to be much more distinct with these lesions. Though it's not shown in this picture, typically with bitter pit, the lesions tend to be centered closer to the calyx end on the as opposed to elsewhere on the fruit. But again, it can be really difficult to try and determine the difference between these two issues. What you want to do when you're looking at that fruit is to try and identify presence of the feeding puncture. So looking under high magnification on those spots to see if you can identify the spot in which the stink bug has been feeding. And then you can also cut through those markings too to be able to see the where the feeding tube has been inserted into the flesh of the fruit. So stink bugs overwinter as adults in protected areas. This can be outdoors in sheltered areas. In the case of brown marmorated stink bug, it's also very common for these pests to overwinter within houses as well. So typically activity can begin in that early season, but injury usually doesn't occur until late summer. And as we mentioned, they've got a wide host range throughout the province in terms of the number of crops that they'll feed on. But the timing and damage really varies depending on the species. And that usually helps in terms of monitoring. A lot of times during the season, you're seeing damage shortly after petal fall or into that midsummer. Then it's often an indication of our native species as opposed to brown marmorated stink bug, where the damage won't start showing up until late season, very close to harvest, or showing up in storage after harvest. So there's no established monitoring techniques for stink bugs. It's really ideal to make note of any stink bug that you observe when doing a regular scouting program. However, there are commercially available traps and lures for brown marmorated stink bug if there is interest for monitoring for this pest. So typically our native stink bugs are not usually of economic concern in apple orchards. The only times that we would really see significant damage caused by our native stink bugs are during times of drought, especially when they're looking for alternate food sources or water sources. It's the invasive brown marmorated stink bug, though, that is of particular economic concern, and that's the one that most are wary of monitoring for. The good news is that there is research that's ongoing right now looking at the efficacy of parasitism for brown marmorated stink bug. You can see in this picture here, this is an image of the samurai wasp, and this is a parasite that is currently being researched and looking at the use of this as biological control for being able to manage brown marmorated stink bug. And this is really important because unfortunately at the present time, there are very few effective chemistries that are available to control this pest. And those that are available are not IPM friendly. So finding alternate ways to be able to manage this pest will be very important in the future. So that brings me to the end of my presentation. If you're looking for more information on any of these pests, I encourage you to check out the apple module on our Ontario Crop IPM website. That information can also be found in our publication 310, Integrated Pest Management for Apples. And with that, I thank you. My contact information is listed here on this slide. Feel free to reach out to me for any questions or comments. I also encourage you to subscribe to our fruit blog at onfruit.ca, and this will give you timely information about Ontario fruit production.